A pleasant day to everyone. Today, we'll be talking all about calculus, about how it came to be, and how we use it in our everyday life. We also got practice problems that is sure to tease your mind. But first, let's talk about the history of calculus. Let us take a trip to ancient Greece where we meet two significant figures. One is Hippasus, whose discovery of irrational numbers is often miscredited to Pythagoras, and the other is Archimedes, who discovered a plethora of ways to find the volume of objects by using its center of gravity to calculate the volume of spheres, cones, and cylinders.
While the Greeks are considered the pioneers of math during that time, let us not forget about the contributions of the Middle East. From the discovery of the integral of the square root of x by Thabit in Qura, a Mesopotamian scholar, and Al-Biruni, who discovered instantaneous velocity and acceleration and who redefined mathematical geography via longitudes and prime meridians. While in the 1600s, multiple European mathematicians pushed the envelope of calculus further. In the early stages, Napier, Sarasa discovered the log function in 1610 and further polished it for 30 years. Then we would have Gregory de Saint Vincent, who discovered limit notion, era of hyperbola during 1620. In 1630, there were two discoveries from separate scholars. First is the axioms for area by the Italian mathematician Cavalieri. The second is Pierre de Fermat, who discovered minima and maxima, which is the lowest and highest values in a given formula. While in the late 1600s, we have 2 years where two principles of calculus were discovered. The first instance is during 1650 with John Wallis, who is the father of the Wallis product, which derives an infinite product, and Blaise Pascal, who created the Pascal triangle, which is used to find integrals of polynomials. While the second instance was in 1690 with L'Hopital's rule for finding limits and mean value theorem for derivatives by rows, and discovery of differential equations by Bernoulli a decade after this set the stage of for calculus in the 1700s, which started off good with the Taylor series, which is the concept of infinite polynomials by Brooke-Taylor in 1710 to 1740. With Euler in 1750, who calculated the curvature of objects, and with the Lagrange multiplier, which is a strategy for finding the maxima and minima of a function with equality in mind. The 1700s became a good successor for the 1600s. Lastly, to cap off this part of the presentation, we would have the 1800s to 1900s, with heavy hitters such as Fourier. Then 1800, he invented the Fourier series, which is approximated by infinite trig series. Bolzano's formal definition of limits and continuity in 1810. Cauchy, in 1820, birthed the residue branch calculus. Weierstrass made convergence uniform with his theorems in 1840. Lastly, in the early 1800s, is Riemann in 1850, who defined integral and fathered differential geometry. As for the late 1800s and the early 1900s, we have Cantor in 1870 with his work on the theorem of sets. Hermite during 1870 found out that E is a transcendental value. Lindman following the same steps as Hermite in 1880 by finding out that pi is transcendental, and Poincare discovered topology in 1890. Lastly is Lebesgue in 1900s with the Lebesgue integral.
Now, if you think about it, we can apply the topics of basic calculus in the Mindanaoan context to deepen our understanding. To start, since February 10, 2020, the minimum fare for public utility GPs or PUJs in northern Mindanao has been 8 pesos. After LTFRB 10 approved the 50-cent fare increase from the current 7.50 peso, here we can use the concept graph of piecewise functions to describe and show situations where a rule or relationship change as the input value crosses certain boundaries. If we aspire to own and drive a car, let's take notice that in Davao City, the maximum allowable speeds are namely 60 kph, 40 kph, and 30 kph, depending on where we are. Here, we can use limits as it tells us the value that a function approaches as its inputs get closer and closer to some number, meaning that the limits will help us determine the possible location of the vehicle as it comes to a specific place or location. Agriculture in Mindanao accounts for over 33% of the country's farming and fisheries production and about 60% of income from agricultural exports, with banana and coconut as the top commodities. Within Mindanao, however, the agriculture sector contributes only to the 18% of the regional economy, lower than that of the industrial sector at 36%. And lastly, agricultural scientists will gather data from samples through the limit theorem to include a larger population. For example, an agricultural scientist may test a new fertilizer on 15 different fields and measure the average crop yield in each area. If they found out that the average field produces 400 pounds of wheat, then the best guess for the average crop yield for all the fields will also be 400 pounds. This is an example of a piecewise function. So, how do we solve these types of problems? First step is to create a table of values that coincide with their set boundaries. In this case, the first boundary is that x should be less than 0, and the second set should be x will be equal or greater than 0. With this, we make our table of values and substitute our x values to come up with our corresponding y values. For example, we substitute 2 to x in the second boundary, x plus 2, which will now become 2 plus 2, equating to 4. After finishing our table of values, we will now determine the types of endpoints that we will be using. There are 3 types: the solid point, which signifies that the point is included, the hollow point, which signifies that the point is not included, and the arrowhead, which means that the point goes on indefinitely. Lastly, we will plot all our points on our graph, and finally input the needed types of point. For example, point 24 will have an arrowhead, point -1, -1 will have a hollow point, and point 02 will have a solid point. In these types of problems, we'll figure out if there is a limit that exists or if a limit does not exist. The first step will be knowing if a limit exists. So first, we will equate the limit approaching 0 from the left and from the right. As the x values approach 2 from the left, the value of f of x is approaching 0. And as we know it, thus the answer will be 0. For the second equation, as the values x approach 2 from the right, the value of f of x is approaching 2. Lastly, we determine if a limit is present. Take note that limits are only present when both limits are equal. In this case, a limit does not exist. We can also say that f of 0 is equal to 2. In this problem, we will be using the limit theorem, limit of identity function, wherein x is equal to c. So our first step will be substituting our constant value, which is 2, to our equation. Thereafter, we will rewrite our problem with the constant value taking the x's place. Now, we will simplify it. First, we have to simplify the exponents, then multiply 2 with the 9, and lastly, we will add everything, and that will give us 47. In this equation, the given is an indeterminate equation. So now, how do we solve this? First, substitute x is equal to c directly into f of x and g of x. In this case, we factor x squared minus 9 into x plus 3 and x minus 3. Given the scenario that we can cancel out x minus 3 from the numerator and denominator, we will now be left with x plus 3. Remember, when handling limits, we use x is equal to c. In this case, our c, or constant, is 3. Thus, our next step will be substituting 3 to all x factors, which will now give us 3 plus 3, and that is 6. Which concludes our solution, because if we get constant non-zero constant, which is 6 in our case, then we found the limit. Now, moving on, tips for the future learners out there: don't stress it out. When solving a problem, break it down into parts so that it can be easily done, and maybe you can enjoy solving calculus problems.